Hello and welcome to yet another chemistry tutorial video. Today we will be going over chapter 10 and how to calculate gas density. If you're ready, I'm ready, let's begin. A landlord has been informed that a toxic fume has been flowing into several apartments. It is later discovered that this is carbon monoxide. If carbon monoxide is being released at 6.5 atoms at 34 degrees Celsius, what is the density of carbon monoxide? So, do you know how to solve it? If so, pause the video now and calculate it for yourself, then unpause the video to see if you got the correct answer. If you are unsure of how to solve it, take the time to copy down this example and follow along step by step. Here are 6 steps that if you follow step by step, you will be able to solve gas density equations without any issues. So the first step is to identify the correct formula or equation to use. The second step is to write out the chemical formula for a given compound. The third step is to find the molar mass. The fourth step is to convert Celsius to Kelvin. The fifth step is to determine the gas constant. And finally, the sixth step is to evaluate for density, which is the lowercase d. So for step 1, all you need to do is identify the correct formula or equation to use, and the formula for that is D is equal to M over V, which correlates to D is equal to PM over RT, and in this equation the D is of course density, the capital P is pressure, the capital M is for molar mass, and then the uppercase R is for the gas constant, and then the uppercase T is for temperature. So if you remember that, you're good to go and you can move on to step 2. So out of all 6 steps, I say that steps 1 and 2 are the easiest because they're just essentially setting up the equation. So step 2 is to write out the chemical formula. And since if we refer back to the question, we were given the compound of carbon monoxide, and that's really easy because carbon monoxide, all the chemical formula is just a C and an O, and that's pretty much it for step 2. Now for step 3 is you need to find the molar mass, and to find the molar mass you need to write out each letter separately, or each element separately, I'm sorry, and then find out by how the amount of them there are. So as you can see, for carbon monoxide, there's only one for each carbon and each oxygen atom. So therefore, you just go look at the periodic table and you look at their atomic mass. So for step 3, we have carbon is 1 times 12.001, and oxygen is 1 times 15.999. And once you multiply those together, you can combine the two, and then that comes out to be 28.01 grams per mole. So much like that weird kid in the class that you don't like, and you want to get rid of him, in chemistry we want to get rid of Celsius and turn that to Kelvin. So if you refer back to previous chapters, the formula to convert Celsius to Kelvin is degree Celsius plus 273 Kelvin is equal to your Kelvin. So therefore, referring back to the equation, we have 34 degrees Celsius, and then so in order to convert, we would just simply go 34 degrees Celsius plus 273, and that gives us 307 Kelvin. So let's keep that in mind, and let's move on to step 5. So step 5 is to determine the gas constant, and if you look to the right, I have provided table 10.2, which gives the numerical values of the gas constant R in various units. So if you look through, we must decide which one to use, and I've gone ahead and circled it. So as you can see, we're using the liters atoms per moles per Kelvin, and the numerical value for that is 0.08206, and so that is your gas constant, which is again the R. And after we have got all this, we may now move on to the final step, which is step 6. Hopefully you have written down all your values, and if not, I have them written down here for you. So step 6 is to evaluate for density, which is the lowercase d. So like I said before, hopefully you have your values written down. If not, I provided them for you. So we don't know what d is, so we can just put a question mark there. The pressure is 6.5 atoms. The molar mass is 28.01. The gas constant, which is R, is 0.08206. And then the temperature is 307 Kelvin. So hopefully you have that formula still somewhere around you. And if not, I have provided it here again. So remember, the formula is D is equal to PM over RT. And just all you need to do now is just simple algebra and then plug in your numbers and solve. So after you plug in everything and do the calculations, your density should come out to 7.23 grams per liters. I hopefully you enjoyed this video. So if you need any more help, please let me know in the comment section below or message me and I will get right to it. Until the next video, have a great day.